Newton's universal law of gravitation. Newton's law of gravitation states that any particle of matter in the universe attracts any other with a force varying directly as the product of the masses and inversely as the square of the distance between them. If we add up all those tiny forces, we get total weight of the body, and if we average the locations of all those equal tiny forces, the resulting location would be the center of gravity. Base of support. An object is in balance if its center of gravity is above its base of support. The line of gravity allows you to assess the balance. If it moves through the base of the support, the object is in balance. The object will tip over the base if the line of gravity touches the ground at a point beyond the base. Staying in balance is difficult when the support base is limited. In such situations, you instinctively shift the rest of your body to change the position of the center of gravity. Balance and height. The higher the center of gravity, the more likely that an object will be out of balance. Weight shift occurs when the center of gravity is positioned in such a way that one leg bears more weight than the other. When the center of gravity is the same distance between the two supports, each support has the same weight. However, if one support is closer to the center of gravity, it supports proportionally more weight than the other. Similarly, if the center of gravity is closer to one support than the other, the support closest to the center of gravity bears more weight in proportion to the distance ratio. Equilibrium. An equilibrium is said to be stable if small, externally induced displacements from the state produce forces that tend to oppose the displacement and return the body or particle to the equilibrium state. For a single particle, equilibrium occurs if the vector sum of all the forces acting on the particle is zero. A simple mechanical body is said to be in balance if it experiences neither linear acceleration nor angular acceleration. Unless it is disrupted by external force, it will remain in that state forever. A rigid body is considered to be in balance if, in addition to the conditions defined for the above-mentioned particle, the vector total of all torques acting on the body is equal to zero such that its rotational motion remains constant. Stability. The ability of a body to restore its original static equilibrium after it has been slightly displaced. In this experiment, a body in equilibrium experiences neither linear acceleration nor turning effect, and unless disturbed by an outside force, will continue in that condition indefinitely. Newton's first law.
The materials used for this experiment are the following. Number 1. Bond paper. It is a high-quality, durable writing paper similar to bank paper. An unlimited amount of bond paper can be used for this experiment to construct a durable structure. Number 2. Masking tape. It is a type of pressure-sensitive tape made of a thin and easy-to-tear paper to adhere to another material. In this experiment, only 1 meter of tape can be used to hold the bond paper together.
Step 1. Roll the unused paper into a cone. Step 2. After reaching the end, stick it with a 2 cm tape. Repeat process for about 40 more papers. Step 3. Insert inward the larger end of the paper. Step 4. Connect the rolled papers by inserting the narrow end of the paper to the larger, crumpled end of another. Step 5. Create 3 different segments. First having 17 rolls, second having 13 rolls, and last having 10 rolls. Step 6. Cut out a strip of paper. Step 7. Align the base of the 3 segments and bind the first and second segment at the tip of the second segment using the strip and a 2 cm tape. Same goes for the tip of the third segment. Step 8. Let the whole tower stand by spreading the legs of the 3 segments.
tower is composed of 3 segments, each with its own purpose. The first segment, which was the longest, stands to be the main body that makes the tower taller. The second segment is responsible to strengthen the limping torso of the tower. The third and the smallest segment is the last part to support and is easily adjustable to cater the weight of the tower. 3 legs of the segments serves as the overall support of the tower, which is somewhat flexible but also sturdy.
During the testing of the sturdiness of the tower, the torso was straight for the most part. However, the structure was seen to be shaking, especially in its supporting legs. The legs may be able to support the whole tower, but it might not be able to withstand when disturbances such as wind and other external forces.
Paper had the biggest part in this course of this activity, and was disposed by having the papers were unrolled, arranged, and stored to use for future bases like fuel.